Hello guys, today we're gonna see how you create a chatbot that is gonna be able to answer questions using as a source your own data. You can feed it with any type of files. It could be either a PDF, it could be either a TXT or a web page. If I'm gonna ask it, what is my first name? Now, by default, this will never be able to know my name. For this demonstration, I'm using the GPT-4 Mini. Now, if I'm going to ask it also, right now I ask it something that it needs to extract information from my own data sources, plus use the data of the model. Now, as you can see, it says you work at software in JP Morgan in London, which is correct. And after it provides extra information of what is JP Morgan actually doing. As you can see, it did a combination of the two. This can actually have many great use cases. I also loaded this page in here that is related to new law around tenancies. If I'm going to ask it what this is going to use directly as a source what I've already fed it. It says, in the UK, under the fixed tenancies will be abolished transition to a system of periodic tenancies. Here are the key points. All assured tenants will be periodic, allowing them to stay in their home until they decide to leave, simply by giving 2 months notice, which is correct. Let's see how we can do that. Now, the first thing that you have to do is create an OpenAI account, add some credits to your account, and after generate a secret key. This is the secret key that you're gonna use for your API calls. Now, as long as you've already done that, you're good to go. You can just copy here and start using prompts and ask the model different type of questions. Now, what we're gonna do is that if you don't have a vast amount of data, pretty much you can send every time all your files directly to OpenAI. The problem is that if you have a whole database and data gets larger and larger, this eventually you're gonna hit a wall, because it first is gonna start becoming really expensive for every API call you do as an input, and secondly, there is an upper limit of, I think it's 512 megabytes, which means that you cannot send more than that. Now, we're gonna use a technique called RAG. So what is RAG doing? We're gonna use the LangChain library. Is we load all our data sources and we break all our data into chunks. After we split it into chunks, we create one embedding from each chunk. So the embedding is a representation of your data as a vector. And after we have a vector database where we save all these embeddings. Now, whenever we do a query to our GPT, to our model, this is gonna first do a similarity search. Pretty much that means that it's gonna find which are the most similar, and it's gonna return only these chunks, and it's gonna only send this in the ChatGPT. In this way, you will never send all the data at once. You're gonna send only some chunks. Now, let's see how we can build a pipeline like that. As you can see, there are a couple of steps that are mentioned in here. Now, the first step is the document loaders, which pretty much refers of how you are able to actually load your data. There are different type of loaders. Now, for some reason, the new documentation here is missing the API reference. I don't know why. So it redirects you into here, but there's not for if you want a detailed API reference with all the classes, you have to use the old documentation of LangChain. Now, but let's keep it simple for now. Now, as a first step, we have to load the file. Now, for instance, this in here we use PyPDF loader, and we use that because the file is a PDF. The next part is the splitting part. This is where we actually split our text into smaller chunks. Now, the chunk size in here is, this represents the number of characters, actually matters, because if you have a smaller chunk, this you might lose context. In overall, it's better to have larger chunk size if you're not sure exactly where to break it. The next step, as we explained, is the embedding part. As you can see, this is a representation of our data as a vector. And last is our vector store. Now, there are a couple of different databases, so that these are used to save our embeddings. And last but not least, this is a similarity search, where you get the most relevant text to your query. Let's see how it looks like. Now, I have created code in here to create the embedding. Actually, I didn't use token. I don't need this in here. So I'm reading the OpenAI key. I'm using a web-based loader to load the URL from here. I'm also using an abstract Word document loader where I'm loading my CV. And after I'm splitting the texts into chunks. Now, this is the separator. The separator is, let's assume that you have used a chunk size of 1000, and the first chunk surpasses the 1000. On the very next step that it's gonna find the separator, it's gonna split in there. It's just gonna split it on the exact 1000 characters. So it's a technique that you can use if you know where to split exactly. In overall, if you're not sure how the data is structured or how it looks like, just use larger chunks. It's safer. Even if the noise is gonna get increased, and the text is gonna be less relevant to when it does a similarity search to your actual query, but still it has better context. And after we create the embeddings and we save the embeddings in our vector database, as we explained, whenever we run the query to ask questions in our own data, first what we're gonna do is we're gonna read our vector store, and then I'm gonna find the 5 in here, as you can see, 5 more relevant documents, and it's gonna return only this. And after, I'm gonna send only these documents to the model, and I'm gonna receive the response back. Now, as you can imagine, if you have, let's say, 5 chunks that are relevant, but here you have a k of 3, this means it's going to return only the 3 out of 5. So whenever you get the response in here, in this part, you won't get all the results you want to. Pretty much that's it. I don't know if you found it really difficult or easy, or I don't know. But hope you liked it, and maybe see you on the next one. Bye.